Okay, so you're just learning calculus, and we got to show that this function and its derivative is 2x. Now, besides using the basic of just putting this thing down here and then minusing 1, which we always like to do, and it's really simple if we just use, the standard way, but you need to use it, find the derivative using the definition of a derivative. And this is the definition of the derivative formula, and I'm going to show you how to use it. Now, let's just first off talk about this. Well, this is f of x, so this is f of x as well. So you just replace this f of x with x squared, and then this is x plus h. Okay, now we're going to get into the roots. So f prime of x. Okay, and this is a limit. We all know what limits are. Limit h to 0. Okay, now f x plus h. What is this really? Well, that, I'm going to erase now, is the same thing as x plus h squared. And then minus f of x, that is exactly this. And then h is just h, right? Okay. Now again, let me just write note. Fx plus h is equal to, x plus h squared. Great, you guys can see that. Okay. This is important. Now, when you're dealing with harder versions of this, remember, whatever x is, let's say it was x cubed, this would be x plus h cubed. Let's say it was x plus 2, so it would be x plus h plus 2. Okay. Again, just don't overthink it, really. And this one, you really shouldn't overthink it. It's just what it is right here. Okay, so let's continue. Oh, that's not where I want to continue. Let's continue over here. Okay, so let's start by doing some algebra 2. So x plus h squared, that's x squared plus h squared plus 2xh. If you don't believe me, I'll show you, right? X plus h, x plus h, x squared, h squared, x plus h, x plus h. That's exactly what I have right here. Now I'm going to delete it all to keep my paper clean. Yeah, and minus x squared. That's just minus x squared, just right there. Don't forget about it. And also, don't forget to write your limit as h minus 0. If you don't write that every single time, yes, you will lose points. You need to write that every single time. That's just part of calculus. I know it feels like very hard to keep writing this. I would always keep forgetting to write this. And in fact, I almost did right here. Okay, well, you can see that there's a positive x squared here and a negative x squared here. So boom, boom, go away. Okay, so this is just equal to the limit as h approaches 0. And we have h squared plus 2xh all over h. Okay, now notice that we have an h term here, a h term here, and h term here. So what we could do is we can do some factoring here. My face over here. So if we factor as many h's out as we can, which is just going to be 1h from the numerator and 1h from the denominator, we'll get the limit as h approaches 0, get h plus 2x or h plus h times 1. And yes, those h's can cancel. Okay, now we are in really good territory. So f prime of x is just equal to the limit as h approaches 0. Now, since there's just a 1 here, this is not going to go away, but anything divided by 1 is just a regular thing, right? So you just don't, I'm just going to write this looking a little bit nicer. So this is just going to be h plus 2x. And look at that. So now, okay, so what you always got to do is you got to wait to do the limit until you can really start doing it. You can't just do it right now. You can't do it there. And you can do it right there at this moment. But right here, this is where it looks really nice. We get 2x, right? If h goes to 0, this is 0 plus 2x, which is equal to 2x. There we go. So a lot of work to show that f prime of x is equal to 2x. Now, that's how.